I today start again complex number. Uh, Hello, hello. Carrying my sound. Today I discuss topic uh, last three lecture three events pride, joint entrance examination. Who are preparing pride, joint entrance lecture. Hello, hello. Carrying my sound. Today I discuss topic uh, last three lecture three events pride, joint entrance examination. Who are preparing pride, joint entrance lecture. Hello, hello. You are following the carrying my sound. Today I discuss topic last three lecture three events pride, joint entrance examination. Who are preparing pride, joint entrance lecture. Hello, hello. You are following the carrying my sound. Today I discuss topic last three lecture three events pride, joint entrance examination. Who are preparing pride, joint entrance lecture. Hello, quadratic quadratic. And now let's see. So first I discuss about quadratic. And now let's see. First I discuss the fundamental theorem of algebra. I discuss about and first I discuss about theorem. Statement in your or in higher secondary syllabus. So I just provide the statement, not the proof. Just only statement. So this statement is that very important to keep in mind. And every algebraic equation, every algebraic statement in your or in higher secondary syllabus. So I just provide the statement, not the proof. Just only algebraic equation. So this statement is that equation important with real or imaginary coefficient or imaginary coefficient every algebraic yes, has at least statement is that equation important at least with real or imaginary coefficient 1 root real or imaginary 1 root or imaginary coefficient at least maybe 2, 3, 4 anything at least 1 root it must have 1 root algebra which is real or imaginary. Yes, as at least statement is that equation important at least with real or imaginary coefficient 1 root real or imaginary 1 root or imaginary coefficient. Now its statement is at least just maybe 2, 3, 4. I am not going to prove this. At least I am going must to prove another topic that a quadratic equation has 2 and only 2 roots. A quadratic equation as at least statement is that quadratic equation important at least with real or imaginary coefficient equation has now its statement is at least just maybe 2, 3, 4. I am not going to prove this. At least I am going must to prove another topic that a quadratic equation has 2 and only 2 roots. A quadratic equation as at least Let's prove this. So, which kind of expression are called quadratic equation? The general form of quadratic equation is general form of quadratic is given by in this way: ax square plus bx plus c, where x is the variable and plus a plus b and plus c are the coefficients. You can look this, the maximum power of x is 2, and so this equation, that's why it's called quadratic equation. So this is the general form. Now we have to prove that it has only two, and just only two roots, just two roots. So we have to prove this. How we can prove this? Look this, we are going to prove. We will take a common, or divide, we will divide this equation by a. You will get x square plus b by a x plus c by a, and 0 upon a is equal to 0. So that's why this will be 0. Now what we can do, we are taking x square here. Here we are taking 2 into b by 2a gives you b by a into x plus, and this is the same, and this is the same. We are taking extra element b by whole square. So this is extra, then we have to subtract this. This will be b by 2 b upon 2a whole square c by e equal to 0. Now this is the formula of a square plus 2b plus b square of a plus b whole square. So this will be x plus b by 2a whole square. And what will be this? This will be b square by 4a square, b square plus b square by 4a square minus plus c by e equal to g. This implies that this will be equal to x plus b by 2a whole square, and this will be simply 4a square. Here it will be b square, and here it will be 4ac equal to g. So we have to find out this value. So we will take it in the right hand side. This will be x plus b upon 2a whole square is equal to b square plus 4ac. Also this will be minus. There is a minus sign in front. There, if we have to take this calculation, there must be take negative sign. This will be negative. B square minus 4ac by 4a square. Now what we will have to do to remove the square on both sides. So we have to take square root. So then it will be x plus b by 2a and on the right hand side this will be plus minus, both side will come, take a root over, this will be b square minus 4ac and this will be 2a. Now we have to find out the value of x. This is the this is the variable. This will be b minus b by 2a plus minus root over b square minus 4ac by 2a. So you can look this. This will be 2a minus b plus minus root over b square minus 4ac. So what are the numbers of root? Actually, roots are called that value of a which satisfies this equation. So here you can find out that x have two values. One is that one if you take one value of x, this is minus b plus root over b square minus 4ac by 2a. So this you will take as alpha. Say alpha. This is different from when you will take negative. Again, x is equal to, we have minus b negative minus root over b square minus 4ac by 2. So this is another value we will take it. This is beta. So both the roots satisfy the equation. The equation I have taken the quadratic equation ax square plus bx plus c is equal to 0. So if you put the value of x alpha here, so alpha also satisfy this equation. I mean to say, if you will take in place of x alpha, then a alpha square plus b alpha plus c must you get find out that it must be equal to 0. Verify this. Your homework this is verify, and also beta is the root, then a beta square plus b beta plus c is equal to 0. This you will must find out. Both will satisfy. So what is the value of alpha? We have find out minus b plus root of b square minus 4ac by 2a. Put there and you will get on the right hand side 0. What is the value of beta? Minus b minus root of b square minus 4ac by 2a. So if you put in place of beta, you will find out 0. So let's check this again. Okay, let's start. So now we have already verified that if you have verified already, you will have found out that the left hand side must be equal to 0 and the right hand side must left hand side must be equal to 0 in the two cases. Both the cases are important, must verify. And now let's move how we have found that for this equation, quadratic equation, we have two roots. So only two roots any quadratic equation can pose. Any quadratic equation can possess two roots only. Two roots only. So it is proved that a quadratic equation can have only two roots. Now we will try to find out how we can represent the quadratic equation in terms of the two roots alpha and beta. How can we represent this? So if we look, what will be alpha plus beta? If we add up alpha plus beta, then we will find out this will be equal to minus b by a plus root over b square minus 4ac by 2a, and here it will be plus minus b by a minus this will be b square minus 4ac by 2a. So this is the opposite, same and opposite sign. This will be vanish and will get minus b by a. So this will be alpha the 8 or sum of the two roots is minus b by a. Now what will be alpha multiplied beta? If we multiply, then we will find out that this will be minus b plus power b square minus 4ac by 2a multiply minus b minus root over b square minus 4ac by 2a. Now, so what will be in the numerator? This will be minus b whole square minus root over. So this is a plus b into a minus b. So a square minus b square minus 4ac whole square by 4a whole square. So this will be b square minus b square plus 4ac by 4a square. So these are same and negative opposite sign, so vanish, and this will be 4ac by A square, then we will get C by A. So you can now find out use this, the alpha multiply beta is equal to C by A, and alpha plus beta is equal to minus B by A. Now we have the equation ax squared plus bx plus c is equal to 0. So now we change the coefficients into uh, the roots form. So we'll again divide the both sides with a, then we will get x square plus b by a x plus c by a is equal to 0. So here what will be? Here we can write down x square minus alpha plus beta is equal to minus b by a. There will be minus alpha plus beta x and c by a is equal to alpha multiply beta. So this is alpha multiply beta equal to 0. So any quadratic equation can be expressed in terms of its roots. So here the quadratic equation is expressed through or by in better term by its roots. You have to keep in mind this form also, very important. Very many questions can be asked in this form. Now we'll go to know more thing about this. So now go to uh, study about what is the role, when roots, we know the number system that it can be real, complex, two types of numbers we know. So what is the value of the roots? Will it be real or complex? In which condition it will be real, or in which condition this will be complex? So this is found out based on the this term b square minus 4ac. This term b square minus 4ac is called discriminant. B square minus 4ac. About what is the role when b square minus 4ac is called discriminant of the equation. It varies as the equation is changed. The discriminant is varies. As 4ac is called discriminant. quadratic equation. So now we have to find out that roots will be will be the properties of the roots based on the value of the discriminant. So you can find out that we have found out that the roots are, I am rewriting one expression minus b plus minus over b square minus 4ac by 2e. So I have turned that here b square minus 4ac is the discriminant. It is denoted by d. D means discriminant. So and now there is a root over on the discriminant. So if d is greater than equal to 0, case 1, if d is greater than equal to 0, then we found the roots are real. Both the roots both are real. So here it can be that I had given two conditions. First condition that d can be greater than and d can be equal to 0. So if d is greater than 0 for case 1, if d is greater than 0, then we have two unequal roots, real roots. Then we have the roots you will found real, but both the roots will be unequal. We have two unequal roots. But if this case happens that d is equal to 0, then we have two roots but equal roots. Then we have two equal roots. This term vanishes and we have just minus b by 2a. So minus b by 2a will be the two roots. We have two equal roots. And case 2 can be based on properties of complex number. Here, if d is less than 0, can be d is less than 0, then the roots must be complex. Then the roots are, both the roots are complex. The roots are complex. So these are the cases. Since here it will come that minus root over minus 1, you know that you have through the complex number that it is equal to iota. So if this is less than 0, then must iota come and it makes the roots complex. Now Now we will go here. This theorem is true for both irrational numbers and for surds or complex numbers. This is true. This theorem is true. This is true for surds and complex numbers. So, what is the theorem? Theorem, it states that you know that surds and complex both have conjugates. Both have conjugates. Any surd have conjugate and any complex number have conjugate. Both have conjugate. So it states that this theorem that for any surd, for any quadratic equation, equation with rational coefficients, rational number, if it has any complex or any root complex or any or a surd, if it has any root complex or for a surd, then the other root must be complex or surd, and the other root must be the conjugate of conjugate. The other root must be its conjugate. First root's conjugate. How we can prove this? Let's prove. Take the quadratic equation is in the form ax square plus bx plus c equal to 0. So its coefficients are a plus b plus c. All are rationals. All are rationals. Now, if it has any root, complex in the form alpha plus iota beta or a surd just only alpha plus root over beta, then actually it is the analysis of this statement, the theorem's analysis. What the statement talks, this is the analysis. So the other root must be their conjugates. Conjugates means, what does it mean? If this is complex, then the other root must be alpha minus iota beta. And if it is a surd, then the other root must be alpha minus root over beta. So it can be very easily proved that it is true. So let's go. I am taking any one, you will verify the other. I am verifying for complex and you will verify for the surd. Verify this for the surd. I am going to prove for the complex. So I am taking one root each complex, the quadratic equations, one root is complex in this form alpha plus iota beta. we have to find out the other equation, uh, other root, and then later we will find out that this is the conjugate. So I am taking the one root each. So its one root is alpha plus iota beta. Now, if this is true, then this root must satisfy this equation. What you will get? We are taking the other root is the other root. Not know this is conjugate or not. We are taking the other root is gamma. So the other root is gamma. Then we know the relation that alpha plus iota beta plus gamma. The addition or the sum of the two roots must be minus b by a. And multiplication of the two roots into gamma is equal to c by a. Now we have we can this root must satisfy this equation also. So we can write down that a alpha plus iota beta square plus b into alpha plus iota beta plus c is equal to 0. So what we will get from this? There will be a alpha square. This will be minus 2 iota alpha beta. There will be for iota square minus 1 beta square. There it will be b alpha plus iota b beta plus c is equal to 0. So from this we can divide it in terms of two parts, real parts and imaginary parts. This will be a alpha square minus a beta square plus b alpha plus c. Here we will take plus iota b beta, there will be minus 2 a alpha beta equal to 0. So 0 can be written down 0 plus iota 0. We know the complex equalities that part must be equal to real part and imaginary part must be equal to imaginary part. We have a alpha square minus a beta square plus E alpha plus C is 0 and B beta minus 2 A alpha beta is equal to 0. So if this is true, then if we take this this is a complex number also, so we will take the conjugate of it. So what will be the conjugate? If we will take the conjugate of it, then it will be A alpha square minus A beta square plus B alpha plus C minus iota B beta minus A alpha beta. So here also it will come, what will it value? Its value is 0, its value is 0. So must will have 0. So now we have to arrange again. We will take E alpha square and from this we will take plus 2 iota A alpha beta, and here we will take A beta square. Here we will take minus iota beta B beta minus B alpha plus C is equal to 0. Just erase this. Now here we can replace in terms of minus iota square. Then if we take A common, the form alpha plus this will be positive, this will be negative plus, so this will be plus and this will be plus, so this will be plus, this will be minus. So here we will get minus alpha minus iota square, just taking here iota square, and here we will get, if we take then we will get alpha minus iota beta plus C. So what is the, we have the, what is the quadratic equation? If you remember, that was ax square, and here it will be positive. This is taken first, so here it will be positive. X square plus bx plus c is equal to. So if you remember that alpha plus iota beta is the first, we have taken the one root of the equation. For the equation a plus bx plus c, so it satisfies the equation, and we have in place of ax alpha plus iota beta, and we have found this. Then taking again the conjugate, we are finding that alpha minus iota beta also satisfies this equation. So the other root must be, the other root must be must be alpha minus iota beta. If one root is alpha plus iota beta,